Hello
Can you hear me?
everyone, welcome back to our YouTube channel, Becoming a ROS Developer. Today we've got Ninat, who has just completed the course ROS2 Basics with Python, and he'll be giving us a presentation on that. So what I'll do is hand over the platform to him now so he can begin his presentation. Alright,
Right.
whenever ready.
Sure. Yeah. Hi everyone. My name is Mehta. Um, I'm going to be presenting the wall follower project on real robot and on simulation. I'll go ahead and start with the real robot first. Uh, I'll just go ahead and start the launch time. Thank you.
Okay.
Right now, it has completed the first two phases, which is um, finding the wall and as long as it's there, probably might want to start it again. And
Struggling
then
to avoid some obstacles there.
yeah, I think I faced it only like once or twice before. But itself sort of self-corrects eventually. But if it cuts too close to the corner and makes a very sharp turn, then it kind of registers the signs or the packet that's there, the red packet, as an obstacle. And from there, it has to perform a full U-turn to get back on its course. Um, I think probably because your laser scan is, or the laser scan on the real robot is registering that as the wall. It's kind of trying to follow that instead of the wall. So that's where the erratic behavior happens. Um,
I'm
but
not
aside
sure
from
I
that,
get your explanation there. So you said the erratic behavior is coming from.
so say right now, as it passed through the red packet, it was at a higher distance from the packet than it was from the wall.
Okay.
Um, and since it was so, it was able to navigate as expected. So it was able to follow the trajectory. But during its wall following behavior, if it gets closer to if somehow the turn is such, or the robot is on the trajectory such that its distance on the left, which is towards the red packet, is lower than that towards the wall,
Mm-hmm.
then it sort of ends up going to the packet instead of the wall,
Oh,
or
so
it
it ends up
basically mistaken the packet
for the
as the
wall.
wall.
Okay.
Yeah, and then it
Mm.
starts circling around. Um, what we saw initially was kind of representative of that, I believe, that it took a sharp turn around the wall
Mm-hmm.
and mistook one of the signs to be the wall, and that's why the jitters and the confusion.
Mm-hmm. Mm-hmm. But so far
Um,
so good. The only failing thing is that it's not stopping when it gets to the starting point. Why do you think that
yeah,
is?
um it was publishing the list of odoms well. Uh, I think my logic with respect to the start distance is, if you, as expected, if you get if the distance between the start point, or whenever the odometry starts, and whenever you reach the start point is less than, I think, 10 centimeters or something, it is supposed to give out a list of odoms. That was working fine, honestly. I am not sure why it's not printing out the list of odoms. Um,
Yeah, so that is the printing out the list of item is a way of data logging, right? It's giving
telling
you
that it's,
information,
yeah,
right? However, the
yeah,
question that I'm asking is, you were supposed to implement a stop mechanism so that when your robot gets to the starting point, it will stop, right? Are
mhm.
you saying what you are suggesting that is not happening is the cause of that?
No, no. So I think one reason was, I'm stopping it right now. But I didn't implement a stop mechanism associated with it. I implemented what I thought. according to the problem statement, if you reach the starting point, you're supposed to print out the list of codons.
Okay.
I did not, I did not understand, like I did not, maybe misunderstood the problem statement of, stopping the robot as well. So it wasn't stopping the robot, it stops the robot only when I terminate it cleanly. It wasn't doing that before. So I haven't coded it to stop, but I have
Okay.
coded it to publish the list of codons, which is, it is, I just tested it in simulation and it's working well. It was working well on the real robot as well. I have a few recorded videos of that.
And
Uh,
what are you using for getting that list of odometric points? Are you using a service, an action, just the
I'm
standard
using
topic publishing?
no, it's action. I'm publishing that as the final point of the action. Like once it reaches the starting point, that's the goal, and then it should publish.
Okay, so only then. So you're not doing any intermediate publishing before you get to the starting point.
I am doing the feedback publishing. If we look at it, so we are getting the total distance, the distance covered. We are getting the feedback publishing, distance from the start point. So we are doing that.
Okay.
So feedback publishing is going as expected. Um, Not sure why the list of codons is not being printed though. It was being printed before because the
What was being printed?
what
Because what values were you getting? Were you getting like actual values, or you were just getting zeros before then?
no, I was getting the values. I
Mm.
can I can probably switch to simulation and show it better.
No worries.
Um,
No
mhm.
worries. We wanna stick to the real robot right now. So, before you stop the script, right? Did you notice that the robot collided with the wall there? Can you give me an explanation of why do you think that happened?
Before we, yeah, I think probably while it was trying to, I think it's with respect to, could be with respect to the speed,
Mm.
that it's 0.2 meters from the wall and or 0 point, like it's very close to the wall, and at that point it's kind of trying to um self correct itself, so it's 0.35 or something.
Mm. Okay.
And then it's trying to bridge that gap from 0.35 to 0.2. In between, it kind of the velocities of the robot is probably high. That's why it just hit in a matter of seconds.
All right. Can you show
Um,
me where that is happening? Can you show me where you are making sure that your robot stays within the bounds?
yeah, inside the code.
Yes. Yes.
Okay. Mhm. So I've set a side threshold
Okay.
and a front threshold, of course.
All right.
And I have this control callback method that I am calling it every zero point 0.5 seconds. And in
And
it is the logic that if it crosses the threshold, then make it, or if it crosses zero point 0.3, then make it go more towards the wall.
and
If that makes sense.
can you explain to me why you chose 0.5? Are you using a timer to call that every zero
Yeah, I'm
point 0.5
using a
seconds?
timer.
All right. So what I
Yes,
want to
I'm using
understand
a timer.
is what led you to choosing 0.5 as your control frequency or control pulse. Why 0.5 seconds?
I did not. I think I could have. I wasn't sure if I could be going lower, higher. I thought I would just be calling it too late.
Yeah,
So
so the reason why I'm asking this, right, is maybe if you had coded more frequently, it would have managed to avoid that crash, or it would have eliminated the winding that we observed, right? But the idea is,
mm,
besides knowing what the actual value will be, right, the idea is for you to play around with these things. That's why we always advise to do multiple tests on the real robot so that you find that sweet spot, right?
hmm,
Yes, so
right.
go ahead.
I think going with the lower value probably would have helped, but I wasn't. I did try with a lower value, and I was getting some communication issue before,
Mm-hmm.
and I just thought I'm calling it way too frequently for it to even register the callback and perform accordingly. So I
Yeah.
increased it and induced a lag, which is again going up the other way. I didn't do much trial and error with the control callback, or the timer, though I should have probably done
So let's look a bit closely on how you're controlling it. Are you using any form of proportional controller, or you're just using if then else statements there? Let's see.
No, I'm just using the if then else statement. I haven't used a proportional controller. I think that could also inducing or using a proportional controller. Yeah, for the real robot would definitely be much better and
Yeah. So
avoiding the gesture.
yeah, definitely. So assuming that if then else worked, because it did work to some extent, right? What were the errors that you were getting when you tried to publish more frequently, or when you tried calling that timer callback a lot more frequent?
I think so I tried with point 1 initially, I believe, and then it was getting closer to say it was trying to turn right, for example, or turn left, probably, or turn right near the wall. It would just keep going straight. I think it wasn't able to register every callback perhaps.
Okay.
This is what I hypothesize. I'm not sure if that was the issue, but with point 5 it was working like a charm. I have tried a couple of runs before, at least a couple.
Yes.
It was working okay.
Yes, so definitely there are some values where if you call it more frequently, it's just not going to work, because then either you will be losing some, or the robot, you have exceeded the limit of what it can process at that point. So
yeah,
understandable. All right. So can you now, let's go to the wall following script. That's the one I want. The wall finding script, right? So I want you to give us a bit more detail on how you managed to allow or create it in such a way that the robot can be able to distinguish between what the wall is and what an obstacle is.
All right, so I'll walk through the script, but the distinguishing point is in general that mostly you use laser scan ranges for getting that. And so I'll start with the code.
And you have preempted something here. So when you say you use laser scan ranges, can you elaborate more what you're doing with the laser scan ranges, right? Because you will process laser scan ranges either way.
Of course, yeah. So what I was doing was initially first I started checking the ranges to the right, to the front, to the left, if the wall is on the left, because for the wall finder you're turning and then turning again to make your wall, to make the robot such that the wall is to the right. Initially I was playing around with indexes. I was saying that if your left range or the index on the left is minimum, go ahead and keep turning left. Then I wasn't considering the angle, which I'll bring into picture later. But the issue I was facing with indexes is, or probably even my logic is that the robot just kept turning.
Yes. Because you're considering one single index, I presume.
Yeah, I was considering one single index, exactly.
Okay.
And two changes I made was, and I was also not considering the latest scan.
Okay.
I was passing the same initial scan to the robot. And for that, first thing I changed was sort of brought the angle into picture, which is, instead of saying that, okay, this is the best index, go towards that, I converted that index to the angle, that this is the angle at which you are finding the minimum index. So, and your current angle, your robot is facing, for example, say 0 degrees, and the angle is at 90. So you keep turning till you can make the angle within a particular tolerance. So instead of, you won't turn a perfect 90, but even if you get to 85, that's good enough.
Okay.
And the second thing, which I think was the obstructing point, was the not using, or basically using a single callback,
Okay.
because I was using the single callback. It was getting a scan message,
Mm-hmm.
going to the wall finder part, using that index value, and it kept on turning,
Mm-hmm.
because it kept on thinking that, okay, at 90 degrees is where my minimum where my minimum range is, so I'll
Mm.
just keep turning.
All right.
Um, so making it into a couple of, or making it into two callback, or basically creating two callback groups, that helps.
Mm-hmm.
So scan is in a different one. The other logic of making the robot turn is in a different one.
Mm-hmm. Mm-hmm. Very,
That
yeah,
was
very good.
uh,
Very much recommended. Um, okay, so
yeah.
now this implementation that you have just described, right? Is this the one that you're still using, where you only consider one index?
No, no. I actually, yeah. So basically, I'm still using the index. That if the index is like, take a window around the scan, and if you find that, for example, the minimum index is at a 90 degree,
Mm-hmm.
convert that index value into an angle value, and then turn around till the angle between the where your robot is currently facing and where the minimum index is zero.
All right, all right. So I'm seeing that you probably run into some limitations when you want your robot to detect the wall, or to differentiate between what the wall is and what an obstacle is, right? So
Right.
yes, and how do you think you could deal with this? Because we saw that there is an issue. We saw that issue is present when the robot was doing the wall following, right?
Mm-hmm.
How
Yeah.
would you address this concern if you were to make this a lot
Um,
better?
I think first thing is, once the wall following starts, I would try to consistently look at the set of ranges in one direction. So from like 0 to probably 90, or one, or something like along those lines, 105 or something.
Mm.
So that, and use those values for it to keep the right wall following intact.
Mm-hmm.
Because right now I feel it's looking at both the sides and calibrating accordingly.
Mm-hmm.
Um,
So it's a very interesting way of doing things. I see myself, because I'm trying to consider, why would you need to look at the other side that you're not supposed to have the robot constantly be aware of, right? Because if
hmm.
you're trying to keep a, a minimum distance of about zero point 0.2 meters from the wall, right? Why would you consider the
Mhm.
left index in all your computations that your robot will be doing, right? Uh, so if I understand you correctly,
Um,
you have something like this happening. So I want to understand why.
I have kind of made the wall following logic such that you can follow both left wall and right wall. So you're getting the same range data. You're computing the minimum on the same ground. But if my variable for wall following is left, then it's basically like, if it's left following, the same computation can be used for it to make it follow the left wall.
Hmm.
So I think
Okay.
that's where I'm faltering.
Okay.
Um,
Okay. So will this, right? Will your current setting allow the robot to do a a clockwise? No, we were going counterclockwise, to do a clockwise loop without any modifications.
it should. Yeah, yeah, it should. Yes,
It okay. Okay, I
I think
see.
so. Yeah.
Okay, this makes sense why you did that. Um, However, the idea of having to control those two variables is two variables. That's what I'm saying, right? Don't you find that to be complex? I want to know, what complexity did you experience when you tried to control those two?
Um, I think for me, I think when I was like basically doing the wall following part, which is the first part of the project, I was thinking more modular, that you could tweak a switch and probably follow both left and right.
Mm-hmm.
But in terms of writing the logic, it's basically you're considering windows, your left range, front range, right range.
Mm-hmm.
So you're considering the entire window
Yes.
and just calibrating accordingly. At that point, I I think I just wrote that with keeping it in mind that okay, I can turn it around and just keep following the ball as I want. I wasn't essentially strictly making it follow left or right.
Yeah, it's a bit complex. It's a bit complex. The one thing that I'm happy about is it works, right? It doesn't really fail completely, but I think it could be simplified, right? And what I'm trying to get to here is, if you were going to simplify your current mechanism, how would you?
Uh,
Yes, how would you simplify it so that you get at least consistent behavior? Because we noticed that it was working, but it would it was very much sensitive to obstacles, right? So it would fail on
hmm,
some obstacles, and if it stayed just within the right tolerance, it would go around in 3-4 laps, and then it would fail with some obstacles, right? So to make it more robust, how would you
hmm.
make your current implementation more robust at the same time simplifying it? Because I think the simpler it is, the easier it is for you to actually get predictable behavior.
Yeah. I think I would essentially first stop considering the indexes on the left altogether. So make
Okay.
my index or make my laser scan window um, uh, small, I would say,
Okay,
or just cut
so
it by half.
having it, so you look at the front 90, I mean the front, assuming that is 0 degrees, and then the
Yeah.
right.
Yeah. While controlling it, I would only look at the values like, front and some tolerance around it and right and some tolerance around it. One way.
Hmm. Okay.
Second way, you already mentioned it, would be I what I think what's happening with the real robot versus the simulation is when the real robot turns, there's this particular angular velocity at which it, or below that it can't go. So it's not
Mm-hmm.
very precise,
Yeah, 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 true.
is what I found. So I think I would induce probably a proportional controller to make sure that if it turns a bit more towards the left, okay, come on, turn it again,
Okay.
and keep on doing that till the direction is right straight in front, or the direction is exactly where we want it to go.
Mm, mm.
Um, I haven't put that proportional into complete idea yet, but that's the concept I would follow.
All right, all right. Thank you very much, Ninat, for the presentation, and also trying very well to explain to us some of the nuances that you came across during your project. So I think what we're going to do is we're going to conclude here, and then we'll finish our
Mhm.
conversation on Zoom, okay?
Okay, I'll wrap anything else for you.
All right, no worries. No need
Okay, yeah,
to. All right, everyone. This was Ninet's presentation, and I'd like to encourage all those of you who would want to try this course that we also offer certification on to do so, and you can also come and showcase your work. Um, then you stand a chance to get the certificate. So until next time, keep pushing.